For all the talk about embedding computers in clothing, here's an interesting option. Make the clothing the computer, and do it without electricity. Mechanical engineers at Rice University's George R. Brown School of Engineering are trying the concept on for size with a set of textile-based pneumatic computers capable of digital logic, onboard memory and user interaction. The idea is to have such textile-based logic gates support pneumatic actuators, potentially in conjunction with an energy harvesting system developed by the Preston lab, to help people with functional limitations with their day-to-day tasks. The research backed by a recent National Science Foundation Career Award appears in the Proceedings of the National Academy of Sciences. Preston said the lab's logic-enabled textiles can be mass-produced using existing clothes manufacturing processes and are resilient enough to withstand everyday use. And in fact, in the last decade, people have been moving towards implementing fluidic logic in soft materials, things like elastomers. But so far, no one had taken the step to implement it in sheet-based materials, a feat which required redesigning the entire approach from first principles. The lab tested its logic on devices that assist users with physical motion and a system to raise and lower a hood with the push of a button. We think there's a host of ways this can be implemented to help people go about their daily activities, Preston said. One of the next areas we're looking into is sensing intent. For example, you might start to grasp an object, and if the system senses your intent, it will give you some assistance in closing your hand around that object so you can lift it up, he said. At the center of the concept sits a NOT gate, a basic component of computer circuitry also known as an inverter. This logic gate's output is the inverse, or opposite, of the input. In an electronic circuit, the gate is on or off, 1 or 0, but the pneumatic gate replaces those terms with high, or low, air pressure. We think of the logic element as, at its most fundamental level, containing both a relay and a fluidic resistor, said Anup Rajapan, a Rice postdoctoral fellow and lead author of the paper. These would be equivalent to having an electronic relay or transistor paired with the resistor, which is the foundation of typical transistor-resistor logic. The pneumatic system depends on a concept Preston describes as a mathematically designed kinked geometry, implemented in pressure-controllable. The valves, each about a square inch in size, are laminated into the textiles and have proved robust enough to handle 20,000 on-off cycles and 1 million flex cycles, as well as 20 cycles in a standard household washing machine. Co-authors of the paper are Rice graduate students Barclay Jumay, Jen Liu and Fei Yap, alumna Rachel Schweda and undergraduate Coulter Decker. The National Science Foundation, CMMI 2,144,809, 2,138,020, 1,842,494, supported the research. Video. u2.be/galgreu_fjk materials provided by Rice University. Original written by Mike Williams. Note. Content may be edited for style and length. Wearables take logical step toward onboard control. Engineers embed pneumatic circuits into fabric for assistive garments. Science Daily, the 30th of August 2022. ift.tt/hqn508l. Rice University, 2022, August 30th. Wearables take logical step toward onboard control. Engineers embed pneumatic circuits into fabric for assistive garments. https://ift.tt, hqn508l, accessed August 30, 2022. Thanks for watching. Please subscribe my channel for more videos.